Hiya there, folks. Root Beer here, looking at question 23, the middle question of Part C on our Grade 7 Gauss. Angie has a jar that contains 2 red marbles, 2 blue marbles, and no other marbles, just the 2 red and the 2 blue. She randomly draws 2 marbles from the jar. If the marbles are the same color, she discards one and puts the other back into the jar. Okay. So if she picks out 2 blues, she puts one of them aside, puts the other blue back in the jar. She'll have the 2 reds that she didn't pick and 1 blue that she put back. Okay. If the marbles are different colors, she discards the red one and puts the blue back in the jar. So it's more likely blue marbles will be going back in the jar. Yeah. Either you draw 2 blue and you put a blue back, you draw 2 red, you put a red back, or you draw a red and a blue and you still have blue. So there's really only one way to lose blue marbles, and that's if you draw 2 of them. She repeats this process a total of 3 times. That makes sense. What is the probability the remaining marble is red? I actually do a similar question like this at a summer camp, but there's it's a much bigger number of red marbles and blue marbles. It's different instructions, and there's always a guaranteed answer. But this is an interesting one because depending on the order you do this process, you may or may not have any red marbles possible or anything like that. So she repeats the process a total of 3 times. What is the probability the remaining marble is red? That the last marble is red. So 3 times is not that bad. I suppose I could make a little probability tree. That's the first thing that's jumping to my mind. It might not be the only way to do the question, but you don't want to spend too much time. You only have an hour to do the contest. You don't want to spend too much time thinking, could I do it this way? Could I do it that way? What's the best way? What's going to be the most efficient? Sometimes it's easiest just to jump straight in and do something. So I could pick, for my first pick, what could I have? I could pick out the 2 blues. I could pick out 1 blue and 1 red. Or I could pick out the 2 reds. And that's going to affect the number of marbles that we have left, which I will then write up above. But of course, these outcomes are not equally likely. Okay, the probability that I pick out 2 blues is going to be 1/4. It's more likely you're going to get a blue and a red. Just like if you flip a coin twice, you're twice as likely to get a head and a tail in some order than you are to get 2 heads or 2 tails. So it's 1/4 probability there, 1/2 the probability there, and 1/4 the probability there. Now if I take out 2 reds, I'll put a red back in, and so we'll be left with 1 red and 2 blue. And, interesting, there's going to be no way to get 1 red down here. Because thinking ahead, on the last pull, either I've already gotten rid of the red at some point, or I'd do a 1 red and a 1 blue, and I'd have to get rid of the red. Things to think about. Well, let's continue on. If I did the 2 blues, then I'd have 2 reds and 1 blue. And if I pulled out the red and the blue, then once again I'd have 1 red and 2 blue. So I can see right now it's 3/4. 1/2 plus 1/4 is 3/4. 3/4 is the probability that after 1 pull, I'll have 1 red and 2 blues left. But actually, there is no way to get rid of all the blues and have my last pull be 2 reds and then put 1 red back. So the answer should be 0. Yeah, so we could instead reason it. I'll finish the tree actually, but let me do some reasoning first. In order to have 1 red left, we would. So this does have a guaranteed answer actually. As long as you start, the only way to have a 1 red left is if you started with only reds. The presence of a blue must always be constant. So that's what we call an invariant. So it is one of the situations I do in my summer talk. Anyway, in order to have one red left, we need the last pull to be 2 reds. So this means before that, we had to have 1 blue and 2 red. You gotta have your 2 reds. But there is no way. Actually, I think this would be easier to say in another way. Just sort of analyzing the rules, not the number of blues, but the existence of blues remains constant. So I like that there's this tricky answer, because I had a little sinking feeling in my stomach when I started making the tree. I thought that's too big for a grade 7 question, but no matter the pull, there will always be blue marbles left. If we pull out 2 blues, yes, you lose a blue, but you put 1 blue back. So there are still blues in the jar. If I pick 1 blue and 1 red, I put 1 blue back, so there will still be blues in the jar. And if I pick 2 reds, I'll put 1 red back. But presumably there would still be blues in the jar. Okay. So we start with 2 blue and 2 red. There's no way to remove both blues. So it's guaranteed that I'm going to get a blue marble in the end, so the probability is 0. But let's go back and finish the tree, just in case you want to practice your tree drawing skills. I'll see what I can do here. Although, I am now going to combine these 2 branches and say 1/4 of the time, or sorry, 3/4 of the time, you'll be left with 1 red and 2 blue. Okay, and so from there I could pick 1 red, 1 blue, or I could pick 2 blue. And I'd be left with 1 red, 1 blue. And the blues would go back, so I'd be left with 2 blues. And then you're sort of forced to 100% of the time take out the 2 blues, put 1 blue back. Forced to take out the 1 red, 1 blue, and get 1 blue back. The probability of this happening, or the probability I pick 2 blues, let's see, there's 3 marbles I can choose from. I could pick the red. The probability I pick the red is 1/3. So 1/3 of the time I'll get a red and then a blue. Is that actually the case? This is how I know it's not going. You're not meant to do this with a probability tree, because I'm sort of second guessing myself now. If I gave the blues names, it'd be 1/3 of the way to pick the red, and then each of the 2 blues is a half, so that'd be 2/6. Yeah, 2/6. So there's a 1/3. So 2/3 of the chance I pick out the 2 blues. That still doesn't seem right. No, it's backwards. It's 1/3 is the way to pick the 2 blues. I miscounted. Alright, then if I had 2 reds and 1 blue, either I pick out the 2 reds, and then I'm left with 1 red, 1 blue. And the probability of doing that would be 1/3. Or 2/3 of the time we'll pick out a red and a blue. And that would leave me with 1 red, 1 blue. So no matter what, at the end of this process, we're going to 1 red, 1 blue. And so then that would leave me with 1 blue. So yeah, there's no chance of me ending up with 1 red. The probability of that happening is 1. And so yeah, that's a wonky looking probability tree, but if you had to work it out that way, that's fine. Although not everyone's going to know probability trees. I mean, I still teach it sometimes in university level courses. I think it's a little easier to sort of realize that you just can't get rid of the blue marbles. But an interesting question nonetheless. I liked that one, and I like that it relates to a talk that I've given in the past to grade 9 students, actually. Anyway, we're going to move on to question number 24. I will see you for that in the next video.